Hi. Oh, look at my dog. I just wanted to say hi. I hope everybody's doing good. Please let me know if you need anything or Miss Martin. And let's hit it. Okay, so I'm going to get rid of this. And where are we today? So PO-4 is wow we are. And it's called factoring GCF. Do you remember what GCF is? Greatest common factor. We've talked about this a little bit. So when we distribute, we're actually distributing the greatest common factor normally. So distribute means to multiply. Okay, because what you're doing is multiplying through by the 2 that's factored outside of this expression. Now, distribute, multiply. What does it mean when we factor? Okay, factor represents division, okay, or to divide. So what we're saying is factor out the greatest common factor. Okay, so between 2 and 6, what's the biggest number I can take out? Well, I can take out a 2. 2 divided by 2 is 1, and it just leaves the x. Plus is the operation. And 6 divided by 2 is 3. Okay, so I factored out the GCF using division. If I want to put the GCF back in, the opposite of division is multiplication. So you would say 2x plus 6, and it's equivalent. So these two things, so 2 equals, okay, so these two things are equivalent expressions. Okay, and what we're going to be working on today is GCF. You always want to try and pull out a GCF first. Okay, so consider the expression 6x squared plus 15x. What we're going to do here is try and figure out a greatest common factor by expanding this expression. So I'm going to say 2 times 3, because 2 times 3 is 6, and then x squared just means I'm going to write x 2 times. Okay. Well, I'm going to use 15 as, let's say, 5 times 3. And I have 1x, so I'm just going to write it 1 time. Okay. So if I look at what's in common, these things are shared. Right? So I can take a 3x out of this and a 3x out of this, and they have it in common. So that means that 3x is actually my greatest common factor. Okay? So I'm going to pull out a 3x from here and here. All right. So I would say 6 divided by 3. Okay. Well, that's 2. Right? And then x squared divided by x. Well, when we divide, we subtract exponents, right? And 2 minus 1 is 1. That means that we still have an x left over. Okay. Plus 15 divided by 3 is 5. And then x divided by x, well, that just turns into a 1. So I don't actually have to do anything here. So if I distributed this thing again, I would have 3 times 2, which is 6. X times x, which is x squared, because we add the exponents, plus 3 times 5, which is 15, and then the x comes along for the ride. Okay? All right, so for each of the following sets of monomials, identify the greatest common factor of each. Okay, well, we can do that. So what we're looking for here, my advice to you is to always try the smallest number, okay? So start with the smallest number and say, does 12 goes into 12, obviously. Does 12 go into 18 nice and even? No, it does not. Okay, so let's think of factors of 12. So I'd have 1 and 12, 2 and 6, 3 and 4. Okay, we're going to try and ignore this side and just look at the biggest stuff, because remember, we're looking for the greatest common factor. So we already said 12 doesn't work. Does 6 work? So 6 goes into 12. Yes. Does 6 go into 18? Of course it does. Okay. So that means I can take a 6 out of both of these terms here. Now this has 3 x's to give, and this only has 1 x to give. So just like we were up here, this expression allowed us to take 2 x's. This one only allowed us to take 1. So that means the most we can take away from that expression is 1, because all this one has to give is 1. So I'm going to take 1x. And then what's left in the parentheses, or in our factored form? So 12 divided by 6 is 2, okay? X cubed divided by x, well, 3 minus 1 is 2, so x squared. Okay, I guess we weren't supposed to write it as, oh yeah, okay, and it means to add, all right. And then 18 divided by 6 is 3. And x divided by x, well, that's just 1. So that would be it. Perfect. Okay, I'm going to look for the smallest number here. So I see a 5. 5 goes into 5. Does 5 go into 25? Oh, yeah, sure does. Okay, so let's write this one as an extended product. So I would have 5, x, 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 1, 2, 3, 4. And then 5 times 5, x squared. Okay, so that means I can steal this. Okay. This is my greatest common factor. That's the most I can take from this. So outside the parentheses would be 5x squared. Okay. And notice here, just like this one we talked about, this only has 2x squared, so 2 x's to give. This one has 4, so I can only take these 2. Okay, so what's left inside? Well, 5 divided by 5 is 1, so I can't write anything here. X to the 4th divided by x squared. Well, I subtract my exponents, and I'm left with x squared. Okay, which makes sense here because what's left over here? 2 x's, or x times x, which is x squared. Plus, okay, 25 divided by 5 is 5. And x squared divided by x squared, well, that's 1. So I don't have to write anything. So that would be that. And also, we see that right here because what's at the bottom left over is plus 5. So these things are the things that go into your parentheses. All right, so the smallest number here is 14, okay? So 14 goes into 14. Does 14 go into 21? Well, I don't know. 21 divided by 14 is 1.5, so no, it does not. Okay, so let's look at factors of 14. Okay, so it'd be 1 times 14, 2 times 7, 3, nope. 4, no. 5, no. 6, oh, okay. So it's just 1 and 14 and 2 and 7. We're going to try and not use these guys. We're going to try and use these ones, but we already said 14 doesn't work. So does 7 work? Okay, well, 14 divided by 7 is 2. 21 divided by 7 is 3. Awesome. So that's going to be my greatest common factor. So in expanded form, I would have 7. 3 times 7 is 21. All right. Now I have 2 x's and 5 y's. 1, 2, 3, 4, 5. Ooh, just snuck it in there. 14xy to the 7th. Okay. Well, 7, so 2 times 7. And this one only has 1x and 7 y's. 1, 2, 3, 4, 5, 6, 7. Oh no. Okay, so what does it share? Shares a 7, shares an x, shares this y, this y, this y, this y, this y, but that's it. Okay. So the greatest common factor is 7, an x, and 1, 2, 3, 4, 5 y's, or y to the 5th. All right. So what's left over? Okay, well, upstairs, what's left over is a 3 and an x. So that means that this should have 3x, but let's confirm. So 21 divided by 7 is 3. X squared divided by x, well, that turns into a 2 minus 1 is 1. So that means that this is an x. And y to the 5th, well, y to the 5th divided by y to the 5th is just 1. All right, awesome. So that's all set. Now down here, it should be 2y squared. Okay, well, let's confirm that. So 14 divided by 7 is 2. X divided by x, well, that turns into a 1. And then y to the 7th divided by y to the 5th, I subtract my exponents. So that means this would be y squared. Okay. All right, we're going to lose the expanded form here. And we're going to try and be smooth. Okay, so let's look at these. 8 goes into 8. Start with your smallest number. Does 8 go into 16? Better believe it. Does 8 go into 24? Sure does. So I know that 8 can come out at least. Now let's look at the numbers. Or the letters, I'm sorry. X. Okay, there's one x that this thing can give. 2x is here. 3x is here. But this is only 1x. So the most I can take out of all three of these numbers is just an x. Okay, so in my calculator, I'm going to say my class knows how terrible I am with 8's times table, so this is solid. 24 divided by 8 is 3. X cubed divided by x, 3 minus 1 is x squared. Or you can think to yourself, I have one x out here. How many do I need in here to make x cubed? Okay, so x squared times x is x cubed. All right, 16 divided by 8 is 2. Okay, there's an x squared up here, but an x here, so that means I need another x there. All righty. And then 8 divided by 8 is 1. And x divided by x is 1, but I don't need to write 1 times 1, so just 1. Okay. All right, so 8 times 3 is 24. X times x squared is x cubed. Plus 8 times 2 is 16. X times x is x squared. Plus 8 times 1 is 8. X comes along for the ride. 8x times 1 is x. Oh my goodness gracious. All righty. These are a lot. I'm going to skip those last two because we have a lot to do here. All right. We're just going forward and doing the same thing. So smallest number is 6. 6 goes into 6. Does 6 go into 10? Absolutely not. So I have 6. 1 times 6. 2 times 3. Try not to do this side. We already said 6 doesn't work. So does 3 work? Nope. So we're going to have to use 2. So I'm going to take out a 2. And this has an x. This has 2. So that means the x1 is the smallest. Okay. 6 divided by 2 is 3. X squared divided by x is just an x. Okay. Plus 10 divided by 2 is 5. And then x divided by x is 1. So that is your factored form. So this would be 6x squared plus 10x. All right, let's look at B. So 3 goes into 3. Does 3 go into 9? Oh, you betcha. So I can take out a 3. Now notice here, this 3 doesn't have any x's to give. So I can't take out any x's. Okay. So 9 divided by 3 is 3. This doesn't have any x's, so this x has to come along for the ride. Minus is the operation, and 3 divided by 3 is 1. Okay. All right, let's look here. So the smallest number I have is a 4. So 4 divided by 4, yes. 8 divided by 4, yes. 24 divided by 4, yes. Okay, so we take out a 4. This has 2 x's, this has 1 x, this has no x. That means that I can't take out an x because this one doesn't have one to give. It would have a negative balance in this bank account, no bueno. So 4 divided by 4 is 1. That means that this just needs an x squared. Okay. Plus is my operation. 8 divided by 4 is 2. X, well, there's no x here, so this has to have an x on it. And then I get 24 divided by 4, which is 6. All right. And then let's look at this last one here. 10 goes into 10. Does 10 go into 35? No. All right. Darn it. 1 and 10. 2. No. 3. Oh, yeah. 2 and 5. 3. No. 4. No. Okay. Try not to use this side. So 10 goes, this doesn't work. 5. 5 goes into 10, yes. Does 5 go into 35 nice and neatly? Oh, yeah. Oh, yeah. I'm going to take out a 5. I have 3 x's to give here and 2 x's to give here. So that means I can take out 2 because this one has 2 to give and this one has 3 to give. So x squared. And now I do a division. So 10 divided by 5 is 2. I have x squared, but I need x cubed. So that means that I need an x in here. Subtraction is the operation. 35 divided by 5 is 7. And I have x squared here and x squared here. That means I don't have to add anything to that thing. Perfect. All right, these are now you tries, so I'm not going to bother with those. Now, this is kind of the challenge one. Rewrite each of the following expressions as a product of 2 binomials. So we only saw expressions involving exponents and numbers up here, but that is okay. If I look here, notice what's happening. I have a multiplication set here added to another multiplication of binomials here. If I look at these, this has something in common. It does have a greatest common factor. Your greatest common factor can absolutely be a binomial, okay? So I'm going to take out what I see is in common. So I see x plus 5 times x minus 1 plus x plus 5 times 2x minus 3. Did I repeat myself? Did I say the same thing twice? Yeah, I definitely did, right? This thing right here is in both of those expressions, both of these terms, okay? So what that means is I can take this out as a greatest common factor. Okay, now what I do is just simplify this thing out. So if I covered this, because I took it out, what's left in here is x minus 1. Oopsies. X minus 1. Okay. Plus is the operation. And then I took this out of here. So what's left in here is 2x minus 3. Okay. So my greatest common factor, x plus 5, and then this is what's left over. So now it says write the product of 2 binomials. So this is not the product of 2 binomials. This is the product of a binomial with 2 binomials being added together. So I have to simplify in here. So out here, x plus 5. Inside, I'm just adding these expressions together. So I have x plus 2x. Well, if I have 2 x's and I add one more, I get x, 3 x's. Okay. And then I get negative 1 plus negative 3. Okay. So negative 1 plus negative 3, which is minus 4. Okay. So now I have the product, which is multiplication of 2 binomials. All right. Last one. I'm going to read it out loud. 2x minus 1 times 2x plus 7 minus 2x minus 1 times x minus 3. Did I say the same thing twice? I sure did. This right here. Okay. That means that 2x minus 1 is my greatest common factor. All right. I take this out, and what is left inside? Well, 2x plus 7 minus is the operation. And then what's left over here is x minus 3. Now notice this one's a little tricky. Ooh, because I have a negative in front of this right here. Okay, so that means I'm going to distribute it. Okay, so I rewrite what I didn't touch yet. Okay, let's see here. 2x plus 7, I'm just going to lose my parentheses because if I distribute this 1, it's just 2x plus 7. Now I'm going to say minus x after I distribute that negative plus 3. Okay, but this is not a binomial. This is a polynomial because I have lots of terms here. So I'm going to just simplify into a binomial by combining like terms. So I get 2x minus x. So 2 minus 1 is just x. Okay. And then 7 plus 3 is 10. And that is it. It's a product of two binomials. I hope you have the most fantastic day. Bye-bye.